Hello students, I am Dr. Navneet Kaur, Department of Electronics and Communications, Sagar Institute of Research and Technology College. Today, I'll be discussing the lecture on the subject Signal and System. The topic which I'll discuss here is convolution of signals. Now first, we will see how can we represent any discrete time signal using unit impulse pulses. Now suppose I have any signal xn. We can see that at n is equal to 0, the amplitude of the signal xn is represented by x0. At n is equal to 1, it is x1. At n is equal to 2, it is x2, and so on. Now, if I want to break up the signal components using impulses, then I'll say that the sample at n is equal to 0, which is x0, it will be written as x0 into delta n. Delta n is the unit impulse which is located at n is equal to 0 and it has strength of 1. Now x0 amplitude multiplied by 1 will give you x0 only at n is equal to 0. So I can write this sample as x0 into delta n. Similarly, if I want to write x1, I can write it as x1 into delta n minus 1, where delta n minus 1 is the unit impulse which is shifted at n is equal to 1. So the sample at n is equal to 1 will be multiplied by this impulse which is located at n is equal to 1, which is having strength 1. So x1 into 1 will give you x1 only. Similarly, x of minus 1 will be delta n plus 1, that is, it is multiplied by the unit impulse which is located at n is equal to minus 1 and x2 delta n minus 2 and so on. So in general form, I can write any signal xn as summation xk delta n minus k, where k is going from minus infinity to plus infinity and k is always an integer. So if I'll write k as 0, it will be x0 delta n. If I'll write k is equal to 1, it will be x1 delta n minus 1, and so on. Now, suppose if I have any discrete time LTI system. LTI system means linear time invariant system, which I have already discussed in my previous lecture. That means the system which is linear as well as time invariant system. Now suppose if I'll give the input delta n, I will get the response as hn, which is the unit impulse response of this system. Now, since the system is time invariant, so if delta n, which is input, is shifted by k units, then the output, which is hn, is also shifted by k units. So delta n minus k will give the response as hn minus k. Now, suppose I want to find out output for any arbitrary input xn, then yn will be the system function operated on this value of xn. So it will be xk system function operating on delta n minus k. Now here we know delta n minus k when operated upon the system function gives hn minus k. So I'll write here as hn minus k. So, and this is the expression for xn convolution with hn. So yn, which is the convolution of input and unit impulse response of the system hn, it will be xn convolution hn, and the formula for the convolution will be given by this summation k is equal to minus infinity to plus infinity xk hn minus k. And this symbol is known as convolution operator, or this yn, and the formula is known as convolution sum. So the output of any discrete time LTI system is a convolution of the input signal with the unit impulse response. So Any discrete time LTI system is completely characterized by its unit impulse response. Now, we'll discuss the graphical convolution example. Here, suppose I have two signals Hn and Xn. Hn is given by four samples 1, 2, -1, where 1 is at n is equal to 0, it is at n is equal to 1, n is equal to 2, and n is equal to 3, which is represented here. Now, similarly, Xn is given by three samples 1, 0, -1. Here 0 I have written with red color because this is the sample at n is equal to 0. So we'll see that n is equal to -1, the sample will be 1. At n is equal to 0, it is 0. At n is equal to 1, it will be -1. Now, if I'll find out the convolution of these two signals, Hn and Xn, we already know the formula for convolution, which is xk Hn minus k. Now, first we will determine how many samples will be there in the convolution sum. Now, always remember the total number of samples in the convolution is given by Lx plus LH minus 1. Lx means the number of the samples in sequence Xn. LH means the number of the samples in sequence Hn minus 1. Here we can see that in Lx is 3 because the number of samples are 3. LH is 4 because number of samples are 4. So the number of samples in the convolution will be 3 plus 4 minus 1. That means 7 minus 1, 6. So in convolution, there will be 6 samples. Now, the second thing, how many samples will be there on the right-hand side of n is equal to 0? And how many will be there on the left-hand side of n is equal to 0? Now, for right-hand side samples, it will be the sum of the number of the samples on the right-hand side of both the sequences. That means here right-hand side samples are 1, 2, and 3. And here the right-hand side samples are 1. So 3 plus 1 is 4. So the total number of samples on the right-hand side of n is equal to 0 will be 4 in the convolution. Now, coming to the left-hand side of n is equal to 0, there is one sample on the left-hand side of x, but there is no sample on the left-hand side of 1. So, the total number of left-hand side samples will be only 1. So, here we will have y minus 1 as one sample on the left-hand side. We will have one sample at n is equal to 0, y0, and we will have 4 samples on the right-hand side, which is y1, y2, y3, and y4. Now, first, we will see how can we find out, say, y of minus 3. Now, y of minus 3, we know we have this formula xk hn minus k, which is equal to yn. Now, if I want to find out y of minus 3, that means here n has having value minus 3. So, I'll have summation k is equal to minus infinity to infinity. Xk h of minus 3 minus k is equal to 0. Now, for xk, I have same sequence, but only variable n is changed to k. So the sequence is xk. The difference is only that here on x-axis we have k. Now this is xk. Now I want to find out h minus 3 minus k. We have already hk, which is same sequence, but only n is replaced by k. Now if I draw h of minus 3 minus k, then I will see that the h of minus 3 minus k, it will be this sequence. Now, if I multiply according to this formula xk into h minus 3 minus k, we will see that when we multiply these two samples, the product of these two sequences will be 0 because h of minus 3 minus k starts after minus 2, whereas xk starts from minus 1. So when we will multiply these two, when these samples exist, here these samples are 0. When these samples exist, their samples are 0. So the product is always 0. Similarly, for y of minus 2, here n will be replaced by minus 2. Now I'll draw h of minus 2 minus k. Again, we will see that the product of xk and h of minus 2 minus k is 0. So therefore, y of minus 2 is also 0. Now coming to y of minus 1. Y of minus 1, that means here n is having minus 1 value. So h of minus 1 minus k. Now if I draw h of minus 1 minus k, it will be like this. Now here if I'll multiply xk with h of minus 1 minus k, then we will see that the only common sample is at n is equal to minus 1. So here 1 into 1 will be 1. Whereas this sequence is not having any samples before minus 1. Whereas this sequence is having, so when we will multiply, the product for these samples will be 0. We have only one sample, 1 into 1, which is 1. Now coming to y0. Y0 means that here we will have n is equal to 0. So xk into h of minus k. When I'll draw h of minus k, I will get this sequence. Now we can see that there are two samples. Here minus 1. This is h of 0, 1. I'll multiply the samples minus 1 and 0 and I'll get the result 2. Similarly, I will find out y1, which will be xk multiplied by h1 minus k. I will get the result minus 2. Then I'll find y2, which is xk multiplied by h2 minus k. The result will be minus 2. Then I'll find y3 and I'll find y4. After y4, y5, y6 will be 0 because again there will be no common samples between xk and h5 minus k, h6 minus k and so on. So if I'll count the samples in the convolution, it is 1, 2, 3, 4 and 5 and 6. So there are only 6 samples in the convolution, and I had already discussed that the total number of samples in the convolution will be 4 plus 3 minus 1, which is 6. So in convolution, there will be 6 samples. Now, these are some basic examples of discrete time convolution. If I want to find out the convolution of delta n, I will get as xn into. It will be only xn. So here, if I want to find out the convolution of unit step function, so here xk un minus k, which is summation k is equal to minus infinity to n xk. Now, if I want to find out the convolution delta n minus n0, so here I'll write hn minus k as delta n minus n0 minus k, it will be xn minus n0. So any sequence xn when convolved with delta n minus n0, that means shifted impulse, it will be the shifted sequence itself. Whereas any sequence xn when convolved with delta n, it will be the sequence itself. Now, there are properties of convolution. First property is the commutative property. Xn when convolved with Hn, it will be same as Hn when convolved with Xn. Here we can see in the block diagram, here Xn is input, Hn is the unit impulse function. It is same as if Hn will be the input and Xn will be the unit impulse. Now, distributive property says that Xn convolved with the sum of H1 and H2 will be same as Xn convolution H1 plus Xn convolution with H2. If I will represent this property by the block diagram, here I can see Xn is the input, H1 plus H2n is the unit impulse of the system. Now it is equal to Xn into Xn convolved with H1n. So Xn is the similar input, common input. It is convolved with H1n. Xn convolved with H2n. Then I'll sum if these two are equal, this says that if two systems are in parallel, then they can be replaced by a equivalent system whose unit impulse will be the sum of the unit impulse of these two systems. Now coming to associative property. Associative property says that Xn convolved with H1 and whole convolved with H2n will be same as Xn convolved with H2n and convolved with H1n, or I can say Xn convolved with convolution of H1 and H2. Now, if I represent it with block diagram, then I can see that if two systems are in series, then they can be replaced by a single system whose unit impulse is the convolution of these two impulse responses. So in short, if two systems are parallel, then they can be replaced by the sum of the unit impulse responses. And if two systems are in series, then they can be replaced by the convolution of the system responses of the two systems. Now, coming to the convolution of continuous time signal. Now, similar to discrete time signal, the convolution of continuous time signal is written as only the difference is that the summation is replaced by the integration and n is replaced by t. So, yt will be the integration of minus infinity to plus infinity. X tau, here k is represented by tau, ht minus tau d tau. So this will be the formula for convolution of two continuous time signals. Now, this is the formula. Here we can solve any numerical for continuous time signal using the same concept as that we had solved in the discrete time signal. We will plot x tau and ht minus tau for different values of tau. We will form the shifted signal, and then we can find the result of the convolution. Now, this is all for today's lecture. Thank you.